In this video, we're going to talk about section 7.2, linear functions and their graphs. First, look at a couple of definitions. A function whose graph is a straight line is called a linear function. And we talked about this already in class when we looked at our equations. An equation such as 2x plus y equals to 7. When we were to graph this, we can find x and y values that make this a true statement, and once we do that, when we plot these ordered pairs that are formed on a coordinate plane, then we will indeed get a straight line. A linear equation is a function because for each input value you will get only one output value. There is one exception, and we will talk about that a little bit later. All equations of the form ax plus by equals c are straight lines when graphed, as long as a and b are both not zero. Such equations are called linear equations in two variables. If we take a linear function, we can find our x and y intercepts. So first let's talk about what are the x and y intercepts. So if I were to draw a graph, draw a coordinate plane, and say we had a line that looks something like this. If you'll notice, this line crosses the y-axis, your vertical axis being your y-axis, at one point, and your x-axis at one point. These points of intersection are the x and y intercepts. Specifically, the point where the graph crosses the y-axis is the y-intercept, and the point where the graph crosses the x-axis is the x-intercept. Now let's approximate where these points are on the line. So let's say this point could be approximately here, so this would give us -4, 0, and this point right here is at 0, 2. So if you think about it, these points will be very similar in the sense that every point on the x-axis is going to have 0 for y. So no matter what point a line crosses the x-axis, the y value, or the y coordinate of your ordered pair, will always be 0 because you're not moving up or down from that x-axis. So here in the x-intercept, your y will always be 0. And the y-intercept, if you think, maybe you're thinking ahead there, in the y-intercept, anywhere the graph crosses the y-axis, as in this point right here, the x is going to be 0 because this is a point on the y-axis. We're not moving left or right, so x will be 0. So the y-intercept, x will always be 0. So you can use this information to actually find the x and y intercepts. So for example, if I had the problem 3x minus 2y equals to, let's say, 12. And I wanted to find the x and y intercepts, I can simply use that fact. The x-intercept is where your graph crosses the x-axis. So going back over here, this is your x-axis. Every point on this line, no matter where that point is, y is going to be 0. So to find your x-intercept, we simply set y equal to 0. So I'm going to come back over here to my original problem, my original equation, and I'm going to set y equal to 0. So I'm going to substitute in 0 for y. And when I do that, that 2 times 0 is 0, giving me 3x equals to 12. Divide by 3, and x is 4. Now, that gives me x is 4 when y is 0. So my x-intercept is actually the point 4, 0. Okay, so then if I were to come over here and find my y-intercept, looking back at my graph, any point that's on the y-axis, so no matter where my graph crosses the y-axis, x is always going to be equal to 0. So we can use that fact here and substitute it in. 3 times 0 minus 2y is 12. 3 times 0 gives me my 0. Negative 2y is 12. Divide by negative 2, and y is negative 6. So x is 0 and y is negative 6. So your intercepts will always have 0 as one of your coordinates. I find sometimes my students have are tempted to put the x-intercept and the y-intercept into one ordered pair, but be careful, the x-intercept and the y-intercept are two different points. So if we were to go back and let me see if I can erase this real quick without taking up too much of our time. So if you were actually asked to graph this function, this linear function, again, it's in that form ax plus by equals to c, where a and b are not both 0. So you can graph it based on what we talked about in class the other day by making a table of 3 values, or you can find the x and y intercept. Again, we found the x-intercept in this problem was 4. We found that by substituting y as 0 because every point on the x-axis, y is going to be 0. So our x-intercept is going to be 4, 0. That's the point your graph crosses the x-axis. Your y-intercept is going to be 0, negative 6. 1, 2, 3, 4, 5, 6. And now you have 2 points. Technically, it would always be best to find one extra point. You can pick any x value and substitute it in to find the corresponding y value. 1, 2, 3, 4, 5, 6. That's supposed to be on that line. To check and make sure that you did this correctly, as I mentioned in class, it's always a good idea to have 3 points instead of 2. So again, the x and y intercepts are simply the 2 points, the points on the axes where your graph crosses. So the x-intercept is where your graph crosses the x-axis, and your y-intercept is where your graph crosses the y-axis, this being the graph of your line. We find the x and y intercepts by knowing the fact that if it's on the y-axis, x is going to have to be 0. If we know it's on the x-axis, we know y is 0. So we substituted that y in, and we got the ordered pair 4, 0. Again, there's your y, that's 0. We substituted in here our x is 0 and got the ordered pair 0, negative 6. Those are 2 different values. Okay, so using the x and y intercepts to graph a linear equation is what we just did, and I'm actually going to cross this one out and put a different equation in because that's very similar to the problem we just did. But let's say that we had to graph the equation 3x, the numbers always tend up being the same when you make these up. So let's say we're going to graph the equation x minus 4y equals to 9. Okay, so I'm going to graph this, and if you're asked to simply graph this problem, you could set up a table, pick 3 values for x, substitute in, and find the corresponding values for y to get 3 ordered pairs, which you would plot on your coordinate plane. But this particular problem asks you to find the x and y intercepts to graph the linear equation. So remember, if your x-intercept is where your graph crosses the x-axis, let me sketch that for us real quick. So it's where it crosses the x-axis. And every point on the x-axis, every point along this axis, y is going to be equal to 0. So to find your x-intercept, we need to set y equal to 0. So I'm going to come back to my equation. I'm going to do x minus 4 times 0 equals 9, and I get simply x is 9, giving you an ordered pair that x is 9 and y is 0. Now, to find my y-intercept, remember this is where your graph crosses, your line crosses the the y-axis. Every point on the y-axis, x is going to equal to 0. So I simply need to substitute in 0 for x. Minus 4y equals to 9. That's going to give me a negative 4y equals to 9. Divide both sides by a negative 4. And y is going to be negative 9 over 4, which we can rewrite as negative 2.25, or 2 and a fourth. Okay, so then when we sketch this, well, let's write that as an ordered pair. Remember, in that ordered pair, x was 0 and y was negative 2.25. Now you have 2 points. You have the point where the graph crosses the x-axis, and you have the point where the graph crosses the y-axis. So this is our x-intercept, so I can come over to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the point 9, 0. And then my y-intercept is where the graph crosses the y-axis, and that's 0, negative 2.25, which will be in here somewhere between negative 2 and negative 3. But a little bit closer to negative 2. Now, that one disappeared on me. Okay, I'm not real sure what's going on. I'm not sure what's going on here. Hold on. I'm not sure why these are erasing. Hold on. Okay. So let's try that again. So I'm going to put the point 90 right here. And I'm going to put the point negative 2.25 right here. And I'm not real sure what's going on, but they're going to go through those 2 points, and that's going to be our graph. So you can see we could do the same thing. We could get these values by using a table. And if you want to treat this, if you want to draw this as a table, here's our x and here's our y. To find the x-intercept, we make y 0. To find the y-intercept, we make x 0. And then you can substitute those values and get these two ordered pairs. All right. Let's talk about the slope of a line. The slope of a line is the steepness of the line. The slope compares the vertical change, or the rise, to the horizontal change, the run, when moving from one fixed point on the line to the other. To calculate the slope, we use a ratio that compares the change in y's to the change in x's. So let's talk about what that means first. So if we have a line, and hopefully this is a review for most of you. If you still have questions, I can just shoot me an email. I'll be glad to discuss this further. So if you look at your line here, this line has a steepness. As we move from left to right, this line is going up at a certain steepness. And when we calculate the slope, we use a ratio that compares the change in y to the change in x's. So you would want to find 2 points, and usually you're given these points, and here I'm going to have this little issue with my points again. Hopefully not. Why? I do not know what's going on here. So here's a point, and here's a point. There we go. Now, so what you're doing is you're actually finding the change in x's and creating a ratio in the change of y's to the change of x's. So in other words, you want to calculate the vertical change. So for this one, we would go up 1, 2, 3, 4, and then your horizontal change, 1, 2, 3, 4, 5, 6, let's say. So there's a vertical change here of 4. A horizontal change here of 6. So it's like if we were giving you directions to get from this point to this point, but we can only go in vertical or horizontal lines and not diagonal lines, I would tell you to get from this point to this one to go up 4 units and right 6 units. And so that gives me a ratio. We use the symbol m to represent our slope, would be up 4, so it's our run, our rise, which is our vertical change, over our run, which is our horizontal change. And we can simplify this to be 2/3. All right, now you can find this same change if you were just given the coordinates and not given the actual picture on a graph by finding the change in your y's. So if we called this point right here x1, y1, and this point here x2, y2, we would subtract your y values, and that would give you your change in y's, over your difference in your x values, which would give you your change in x's. And this is our slope formula. And you know, it's good to remember the slope formula is y2 minus y1 over x2 minus x1, but really it's even better to just understand what you're doing. You're finding the difference in your y's, your y's, and you're creating a ratio of the difference in your y's and your difference in your x's. Now, a common question that I'm asked here is, does it matter which one is your x1, y1, which one's your x2, y2? It does not matter at all as long as your x1 and your y1 come from the same point and your x2 and your y2 come from the same point. So these values here need to be one coordinate, and these values here need to be the other coordinate. It doesn't matter which one you call x1, y1, which one you call x2, y2. Okay, let's look at an example. In this problem, you're asked to find the slope of the line passing through the following pairs of points. So I'm going to show you this two different ways. The first way I'm going to do this is by using the slope formula. The slope formula is y2 minus y1 over x2 minus x1. You subtract your y's and divide it by the difference in your x's. So I typically just call my first point x1, y1, and my second point x2, y2, and then this is just a matter of substituting. So here, y2, which is -2, minus y1, which is 4, and I will always put that in parentheses, just because if this was a -4, you want to remember to keep that negative. And then my x2 is -4 minus, and here's an example of why you want to make sure. That's why I just like to put it in parentheses. So -2 minus 4 is going to give me a -6. -4 minus a -3 is a -1, and this simplifies to a +6. If we want to write this as a ratio, we can write it as 6 over 1. All right, let's go and put those points into our coordinate plane. So if I go over here to -3 and up 4, so one of my points is -3 up 4. So this is -3. I'm not really sure what's going on here. -3 and 4. And then my other point is -4, -2, so -4. And down 2. So here's my other point. Oh, this is crazy. Sorry, I apologize. And what is going on? All right, -4, -2. And if you were to draw a line between these, it would look something like this. And this is -4, -2. And suppose we wanted to find the slope this way. I want to look at my vertical change from one point to the next. So to go from this point to this point, I would go up from here. I'd go up 1, 2, 3, 4, 5, 6 units. So it's a vertical change. Let me put that over here, of 6. And then I go right 1. And it's a horizontal change of 1. So you can see you can find that slope by using the slope formula, or if you have a coordinate plane in front of you, you can find the slope by counting the vertical change and creating a ratio with the horizontal change. All right, let's look at another example of this. So here, let's find the slope using the slope formula. So I'm going to take I'm going to label these x1, y1. x2, y2. My y2 is 5 minus my y1, which is a -2. My x2 is -1 minus my x1, which is a +4. And when I do that, 5 minus a -2 gives me 7. -1 minus 4 is a -5. So my slope is a -7/5. Alright, so I'm going to draw this one. So 4, negative 2, I already have, let's see, 4, negative 2. Let's see if I can do these on the same graph. 4, negative 2. And negative 1 up 5, 1, 2, 3. So negative 1 up 5 is going to put me up here. So this is negative 1, 5, and my 4, negative 2 has already disappeared. And let's see what happens when I go from one point to the next. So I'm going to start, I always tend to start on my leftmost points, but it doesn't matter. But to get from this point, my first point, to the second one, I'm going to need to go, let me pick a different color. I'm going to need to go down 1, 2, 3, 4, 5, 6, 7. So since I went down, that's going to give me a negative 7, and then I have to go from there, I have to go right, 1, 2, 3, 4, 5, and a positive, since it's to the right, it's positive, giving me the slope of negative 7/5. So you can see that you can find the slope if you have a coordinate plane and you want to plot the points and calculate the slope by just counting. You can do it that way. Or you can use the slope formula. Find the difference of the y's. It's a ratio of the difference of the y's to the difference of the x's. Your vertical change to your horizontal change. Alright, so let's go back and look here real quick. If you have notice what happens when we had a positive slope. Our graph, this green line, was increasing. We read our graphs the same way we read anything from left to right. So the green line, as you move from left to right, is going up, and it was a positive slope. The blue line, as you're moving from left to right, is going down, and notice we have a negative slope. Alright, so here you can see a possibility for our slope. As your line rises from left to right, our graph increases. We have a positive slope. As your line falls from left to right, your slope is negative. If your line is horizontal, your slope is going to be 0. And if your line is vertical, your slope is going to be undefined. And the reason is, let's say we had 2 points right here. Here's a point, and here's a point. If you're using your slope formula, when you subtract y2 minus y1, maybe you'll get 5, but your x's, there's no change in your x's, so that would give you 0, and anything divided by 0 is undefined. Same thing here for our horizontal line. Your change in x could be 5, or excuse me, your change in y's when you have a horizontal line, there's no vertical change, so that's 0, and then your change in x's could be, say, 3. Anything divided by 0 divided by anything is simply going to be 0. So a horizontal line, your slope is always 0, which is an actual value, and a vertical line, your slope is always undefined.